Okay, Math God Adams here. We are on block 5 from topic 4. This is on page 117 in your workbook, so if you aren't there, get there now. First thing we're going to look at is I have a target here on the board. It's kind of like a darts target, or if I'm shooting a bow and arrow, a target that I would shoot at. What are they aiming for when they're shooting here? The yellow circle in the middle, they kind of call that the bullseye. So I see one of the arrows is dead center in that yellow. That's kind of our goal, right? Is to be dead center.
Yeah.
And I get points when I shoot it in the yellow. Yeah, I get more points, right? Because it's worth more points. Okay, well what if I shot my arrow in the yellow but it wasn't dead center? Do I still get the same amount of points?
No.
Yes, you do, because it's in the middle still.
It's still in the yellow. It's still in the yellow category. It doesn't have to be dead center. It's cool when it happens that way, but you don't have to be. So if I was off a little bit from the dead center but still in the yellow, I have what's called a percent of error. And that percent of error would be okay because I still get the same amount of points, right? So my error is good. What are some other situations where your error is acceptable and it still gives you a decent outcome, the outcome you were looking for?
I have a question. So what happens if you land in the yellow, but you also land in the red?
I don't exactly know what happens with darts. Is that just a faulty shot?
Yes. You have to start.
I think it's like a rethrow.
If you get it in red,
Like
In
half
the middle.
in the middle of the two
Yeah.
colors.
Yeah, you
I'm not
just restart.
exactly sure what
You
happens.
just restart the
It's
program.
been a long time since I've played darts. So anybody have some ideas of what some error would be that would be okay because it's still leading to my target? I'll give you an example to get your brains thinking. Looking back in the back of my room, the average scale for our grades. When I get a report card and it says an A, does it exactly tell me that I got a 4.0 A? No, that's what I'm striving for, but it could have been off a little bit and I still got an A, right? Okay, I could have been a 3.5 and still got an A. So that is an acceptable range. 4.0 is my target, but I could be off a little bit and still get an A. Any other ideas that come to mind?
When you pour 2 cups of lemonade, but you get 1.75 cups instead of 2.
She can read a problem.
I know, right?
Yeah. Any
Like,
other
like-
real life
Like,
things?
I don't think I can.
Those brains aren't working?
Like if you're on the ball field and you're going for the 10-yard, and like you make it in the half of the 10-yard.
Okay,
That makes no sense.
she's thinking they would make you start at the 10-yard when you've already went to 10 and a half, but they actually make you start right there at the 10 and a half. But I was thinking football as well. When I shoot a field goal, do I have to shoot it directly in the middle?
No.
It can be anywhere in that range, right? It can even be super high up as long as it's between those two poles. What do you got?
During in baking, when you're striving to like get 2 cups exactly, but sometimes you get a little over, a little less.
Okay, so in cooking, you sometimes can't get exactly right, or you might mess up a little bit. That's kind of how new recipes start, is we mess up and we might make it a little more peppery and it turns out being pretty good that way, and we might want to keep it that way.
and that's kind of Brianna told me that what I don't know her.
It's fun.
I just have like a 17-year-old and she looks just like me. So anyway, when she mentioned baking, like let's say if it was like 5 minutes or like 10 minutes,
Oh.
and even if you're a little late, a couple seconds off,
Still good.
yes,
It's
ma'am.
not burnt. I like that idea. I haven't had the time one all day. What about
Temperature?
baseball?
Yeah.
If I'm pitching,
It
a
has to be
strike
over.
zone is an acceptable percent of air.
Oh.
If it's inside and they still called it a strike, it was okay
To them.
to them. But it was in their acceptable percent of air. Okay, so there are many different scenarios we can go into. I'm going to intro our problem we're working with today. And it says Haley and her teammates decide to sell super sour lemonade at the first basketball game. Super sour lemonade contains 20% lemon juice, 80% sugar water. They will use pitchers that hold 10 cups. When Haley and her teammates make the lemonade at the game, it will be very busy and they will not have time to carefully measure the ingredients. How could they estimate the amounts and still create a beverage that tastes like super sour lemonade? So yesterday we looked at what it takes to make super sour lemonade. Now they're going to be behind the counter running around trying to make this really quickly. Are they wanting to get little small measuring cups and have to sit back there and try to do that really fast to measure all my ingredients? No, I want some sort of quick method to use. I also don't want to just sit there and pour randomly the sugar water and say, that's probably good. You have an idea?
Yes, ma'am. So if she poured 1.75 cups, but she needs 2 cups, she could just make a whole new pitcher and then pour some of that to make 2 cups
Okay,
instead of.
what you got?
You could put Mike's down in the picture so we put the lemon juice in the foot that way and you put the water in how much it should be when you put the water in.
Okay, she said, I could put marks on my picture. I could measure it out the first time maybe. Put marks of where it should land. And fill it up until that amount and then mix both of them together and be ready to go. That's kind of how I thought about doing it at first. So we're going to look at a couple different people's methods and we're going to look at their percent of air. Before we do that, we need to actually define percent of air. So we're going to put this on a sticky note so it stands out, but it's going for number 1 in our book. And percent of air is the amount of air divided by the target measure. When you divide that, you then multiply it times 100, and you will have a percent of error. So write that on your sticky note, and it goes for number 1. That way it stands out so we can find it. Alright, so now we're going to start the problem. The majority of our problem is going to be done up here on the board, and we're just going to discuss a few things. So we're not writing right now, so have your writing utensils down. We're just watching. And it says Haley and 2 friends will pour lemon juice into the 6-cup pitcher until they find that they have poured enough. Then they will measure and record the percent of error. Finally, they will conduct a taste test. So all 3 of them are going to try their methods and see who has a better outcome. So Haley is up first. And Haley decides, well, they all decide they need 2 cups. So she pours a little and she says, nah, that's not it. That's probably it there. And do you think she had any kind of reasoning or rationale to her pouring?
No.
It didn't seem so. Okay, well, we get a shot to try next. So I have a 6-cup pitcher, and we want to fill it with 2 cups. And I want to try to get as close as 2 cups as I can. Where should I stop pouring based on this 6-cup pitcher?
On the
Right
fill
there,
line.
bottom handle is.
The fill line?
No.
I want 2 cups.
Oh, 2 cups.
Bottom of the handle, the top of the handle, middle of the handle,
Bottom.
Probably the
halfway up,
No.
bottom of the handle.
bottom of the handle. You think
No,
would be
top of the
2
handle.
cups?
Top of the
No,
handle.
no.
Because half of that is 3
The
cups.
top of the handle is
Half
not
is
2 cups.
3.
Yeah.
So like,
Top.
Well, half of the whole thing is 3.
Yeah, top of it.
So top of the bottom handle.
Okay.
top.
So what's gonna happen is I'm gonna click this pour button, and when you see the liquid go to the level that you think is good, you're gonna shout stop.
Stop.
So here we go. Watch the liquid and tell me when I need to stop. I'll be listening for you. So liquid is going in, going in.
Stop.
Hold.
All right.
We're so close.
So they calculated my amount of air. I was how far off from 2 cups?
0.2.
0.2 cups. So I was a little more. 0.2 more. Then I took my target amount. What was I shooting for?
2 cups.
2 cups. When I divide that and multiply it by 100, I get the percent of air. What was my percent of air? 10%. That wasn't too bad. Pretty close.
Can we do it?
No, we know where to shoot for now.
Yeah, exactly.
Yeah, let's
Okay.
That's the point.
So we're gonna go back to Haley, and Haley is gonna pour what she poured a minute ago and see how much she actually poured and see if she was good. So she poured her contents.
Same.
She was a bit off, huh?
Yeah.
We did better than her.
So she takes those 2 amounts and plugs it into my formula here. We take our amount of air, we subtract those 2 to see what our difference is. Our target amount was 2. So what do I need to do to 2.5 and the 2?
Subtract 2.5 and 2.
I need to subtract them. Then when I subtract them, what do I do?
Divide that.
So I subtract, I get 0.5. 0.5 divided by 2 gives me 0.25. Times 100 gives me 25%. So what was her percent of error?
25.
25%. Our percent of error was what?
10.
10. Who did better?
Us.
We did better. She was off a lot more than us. Okay? Now we're going to look at Vanessa. Vanessa is going to pour, and this goes along with number 2 in your book. So let's read number 2 in your book. If Vanessa intended to pour 2 cups of lemon juice, but she actually pours 1.75 cups, what is her percent error? So we're going to watch to find this. And when they do the math work, that's what you should be writing for number 2. So here they go with the math work. She poured 1.75. What was she supposed to pour? 2. So I need to see how much she was off by. So I need to subtract that. Our target was 2. So I'm going to subtract that. I get 0.25. I divide it by 2. Multiply it times 100. What was Vanessa's percent of error? 12.5%. So, did she do better than Haley?
Yes.
Did she do better than us?
No.
No.
Nope, we're still in the lead.
Yay.
So this math work should be written for number 2 if you don't have it written.
What's number 1?
The
The
sticky note.
sticky note.
Oh, that's
Yes.
the answer.
Does anyone need more time to write this for number 2?
Yes. I just started.
All right, that was Vanessa. Now Juan is up. Juan, let's see how he does. So let's watch Juan. We're not writing right now. He pours, and he had poured 2.25 cups. So he needs to calculate his percent of error. So he subtracts the 2 amounts. His target was the same as us, 2. We're gonna subtract and then divide. When I divide that, I get that. I multiply it times 100, and his percent is 12.5%. That sounds familiar.
Because,
Makes
oh, it was because
So, raise your hand. It's the same as who?
Vanessa.
Y, raise your hand. Y is Vanessa, and Juan's percentage is the same. They poured different amounts. They both got 25.
I don't know what she means by that.
Okay, explain further.
So we're supposed to reach for 2, but Vanessa's she had 25% less, or well 25. I'm gonna say ounces, I guess. I don't know. Whatever it was. Hundreds, yeah. And since she poured 1.75, she got 2. She was 25 down, and then when Juan poured his, he was 25%
Above.
above. Yeah.
They're both trying to aim for 2 cups of lemon juice, but one is more. They're both aiming for 2 cups of lemon juice.
Okay, so what we're gonna write, we're combining everybody's response here. One poured, you're writing this, so everybody's writing utensils is moving. One poured 0.25 too much.
Too much. No, too much.
Vanessa poured 0.25 too little. They both were off the same amount. Juan poured 0.25 too much. Vanessa poured 0.25 too little. They both were off the same amount. So back to that target thinking, if my target is this little bullseye dot on my marker board, and I shot, and my shot landed right here, a little above it. Then a hunter shot, and he landed right here. We're the same distance away from the bullseye, but is it the same spot? No, I shot above it, Hunter shot below it. We're still the same distance away.
It'd almost be like positive and negative.
It is almost like positive and negatives, right? Very good thinking. Alright, so the last video clip, they're actually going to taste test it and see if they can use any of the 3's lemonade mixtures. We can probably tell by looking at lemonade mixtures. If I had a target color, like my paint recipes back at the beginning of the school year, my lemonade color should look the same if I want it to be close tasting to it, right? So if it's too bright yellow, that means it has too much lemon juice. If it's too light looking, it's got too much sugar water. So let's take a look at them taste testing. So they test Juan's first. His color looks pretty close. It's a little darker. They said it tastes pretty close. Vanessa's is a little light. They said it tastes pretty close as well. Haley's is awfully bright. Ooh, I believe they don't like it. They were shooting for super sour, and I think Vanessa's got extreme sour. And you could even tell by the colors of Haley's that it is awfully yellow compared to my target color here. So they decided that what percent of air was okay for the lemonade. 12.5. Was Haley's 25% okay? No. Would our 10% air be okay that we got? It would have been fine. Okay, so that is the lesson. Problem 4 and 5 is for homework. Thanks for listening. Like, subscribe, hit the notification bell, and peace out, home dogs.